All right, so now that you have a table of values and a graph for your data, we are actually going to start creating a function to describe what is going on. And this is going to be a really difficult part of the challenge. I don't expect you to like completely master it right away, but hopefully we can work through it using guess and check, logical thinking, and I'm pretty confident that we'll have some leeway with this today. So essentially a function, go ahead and write this down on page 6 of your notebook. Title that page Creating a Function. And you're going to go ahead and write down the definition of a function. There are different ways of saying the definition. For now, this is what I'm going to write it as. So a function is a relationship between inputs and outputs such that for every input, there is only one output. I know that's a lot of words, but hopefully, you know, this relationship between input and outputs is something you're zooming in on. Well, like, hey, that's what we've been doing this whole time, right? We've been looking at some input and some output with my data. So for me, I was looking at the input of the year, and my output was the number of advertising seconds, right? So this is something we can use to show the relationship between our inputs and our outputs, okay? So to create a linear, so we're going to focus on linear functions. So hopefully your data worked out so that it creates pretty much a straight line. And if not, we're going to talk about creating a line of best fit. So even though your data doesn't make a perfect straight line, we can approximate. So there are two parts to this video. One, okay, part one, creating a function for a linear relationship. And then part two will be creating a best fit line if your relationship isn't 100% linear, okay? So if you have a pretty much linear relationship with your data, the way to create a function is to just kind of guess at first, right? So for everything you do, you're gonna have a relationship between your input and your output, right? You're going to put in some input and it's going to result in an output. I'm so sorry. Okay. Your input's going to result in some output. So for example, if I put in the year 2009, my output is going to be 805 seconds, right? So there is some machine that when well, it's not exactly a machine, but you can think of it that way. There's some machine that when the input is 2009, the output is 805 seconds, right? So for every input I have, I get out something. And then after that, there is an increase of 12.5 seconds until, or we'll just say there is an increase for every year, right? So we know that we start somewhere. We start in the year 2009. Oh, let's look at our graph. We start in the year 2009 with 800 seconds. And then for every year we go up, we have an increase of 12.5 seconds. So for every 1 year, I go up 12.5 seconds. Okay, so there's some pattern, and we can express this pattern with a function. So let's put in words everything that I just said. So we start in the year 2009 with an output of 805 seconds. For every 1 year after that, we increase the output by 12.5 seconds. So these are in words, okay? So I want you to first look at your data and your graph and try to write out in words what's going on. I want you to think about where you start, so starting input and starting output, and then how much you increase or decrease per unit of time. So per year, per month, per day, per week, whatever it is you're looking at, look at approximately how much you're increasing or decreasing by. Then write it out in words like I did right here. So this is what I'm trying to get you to say. when you start and what you start out with, and then for every unit of time, what is your increase or decrease. So go ahead and pause the video here if you need the time, and then start up again when you're finished writing your sentence. Okay, so hopefully you were able to write down the written explanation of what's going on with your data, okay? Now, how do we actually take this written explanation and begin turning it into an expression? So here is our written, and we are turning it into a mathematical expression, right? So instead of writing out this long version, how can we make it so that we can write an expression that represents this and you would understand they mean the same thing? So I'm going to give you an example of that, okay? So an example of turning a written explanation into a mathematical expression. So an example, Jennifer and Alex bought, well, let's do it this way. Jennifer bought 2 shoes. Alex bought 3 shoes. Okay, that's a written explanation of what happened, right? Jennifer bought 2 shoes. Alex bought 3 shoes. To turn this into a mathematical expression, we know it's 2 shoes plus 3 shoes. Okay, together, okay, let's add this. Together, they bought 5 shoes, right? So the written explanation is Jennifer bought 2 shoes, Alex bought 3 shoes, together they bought 5 shoes. In math, we write it as 2 shoes plus 3 shoes equals 5 shoes, right? So these mean the same thing, right? They represent the same situation. However, this one is a written explanation, this one is a mathematical expression. So 2 plus 3 equals 5, right? So that's exactly what we're going to do with our data. We're going to start out with this written explanation, and then we're going to turn it into an expression, into a function, okay? So let's first start out with the starting, okay? So I know that when I put in the year 2009, my output is 805 seconds, okay? So I'm just going to start with, so when I put in 2009, I should get some kind of 805 seconds, okay? So that's a little tricky because we, 2009 is not equal to 805, right? There's no way we can make these two equal. But there's stuff I can do to the year 2009 to make it become 805 seconds. So maybe one thing I can do is I can subtract, right? So 2009 minus, 2009 minus 1204, so 2009 minus 1204 is equal to 805, right? So I can take my input and subtract 1,204, and I am guaranteed to get 805 seconds. So far, so good, right? So I'm going to go ahead and my input, I'm going to take away 1204, and then I'm going to get 805 seconds. So maybe my function is starting to look like my input minus 1204 equals my output, okay? So I'm essentially saying, okay, take whatever input you have, take away 1,204, and then you'll get the output that you want. Now, let's see if that's true, right? If I put in 2010 and I take away 1204, I should get my output for 2010, which is 817.5, right? So 2010 minus 1204 is 806. So that is not the output I want, not the output for 2010, right? The output I want for 2010 is 817.5 seconds. So that doesn't quite work. So I'm going to play around a little bit more. Okay, so I'm like, okay, well, I know that I'm not going to take away 1,204 seconds. Maybe what I can do is, so I'm going to try something else. I'm trying to turn 2009 into 805 seconds. Maybe I can do this. 2009 minus 2009 is 0. Okay. Then I add 805 seconds. Okay. So maybe what I need to do is subtract 2009 and then add 805 seconds. So if I do 2009 minus 2009 plus 805, you can see that that is 805. So I get the output that I want. Okay, so maybe what I actually need to do is take my input, subtract 2009, then add 805. And that will give me my output. Okay, so hopefully that sort of makes sense. Okay, let's try it with 2010. I'm going to go ahead and put my input to be 2010. So 2010 minus 209 plus 805 equals 806. So I'm still not getting the output that I want. However, this is when I want to start looking at this rate of change piece of our information. So remember, I asked you to take a look at how much is your information, your data, increasing or decreasing over time, right? And I noticed that whatever input I have, so whatever my input is here, it's going up by 12.5 seconds every time. So if my input is 1, it's 1, I'm going up by 12.5. If I have after 2 years, it's 12.5 times 2. So since my output is increasing by 12.5 seconds every year, okay, maybe for every input I multiply it by 12.5. So essentially I'm saying, look, whatever year you're at, you're going to multiply after 2009, right? Because I got to take away that 2009 at first, okay? Every year after 2009, you got to multiply by 12.5 seconds because you're going 1 year is 12.5, 2 years is 12.5, and then another 12.5. 3 years, 3 times 12.5. Plus 805. So I took this initial expression, this initial equation I came up with, and I'm putting into account the rate of change, how much I'm going up per year, okay? So let's try this, okay? So let's try it for input is 2009. Let's try it when my input is 2009. So I would get 12.5 times 2009 minus 2009 plus 805 equals, so 12.5 times 2009 minus 2009 plus 805 is 805. So I got the correct output. Okay? Let's try it when the input is 2010. So I know that I'm increasing every year by 12.5, and 2010 minus 2009 plus 805. Let's try that. And I got 817.5. So as you can see, it's starting to look like this is a function that models my data, right? For every year I start out at 2009. That's kind of my year 0. And it started out with 805 seconds. Then for every year, I went up by 12.5 seconds. And, starting from my starting point. So it looks like a function that works is I take my input, I subtract 2009, I multiply that by 12.5 because I'm increasing by 12.5 seconds every year. And then I add my initial 805 seconds. So I started out at 805 seconds. And so I can't forget that, right? I don't want to start over here at 0. Whoops, sorry. I don't want to start here at 0 because at 2009, my initial piece of information was at 805 seconds. Okay? So it looks like a function that works is take your input, subtract 2009 from it. So I'm going to verbalize this again. Take your input and subtract 2009 from it. Then multiply it by 12.5 and then add 805 to get your output. Because, I'm going to go ahead and write an explanation why. Because 2009 is your starting year. It is like your year 0. Okay? Then multiply it by 12.5 because, right, for every year after 2009, you increase by 12.5 seconds. And then we add 805 to get your output because 805 seconds is where we started, right? That was our starting point, okay? So hopefully this kind of guess and check that I did with our information makes sense. I didn't get the correct function at first. I was just kind of guessing around to see what works. And that's okay if that's what you do as well. It's kind of try to experiment and see what works. But always take into account these two pieces of information. Where did you start and how much are you increasing and decreasing over time? Again, I'm more than happy to help you with this process in workshop and during class. So, go ahead and take your data, your graph, your table, and see if you can create a function that describes what's going on. When you put in your input, what becomes your output? How do you get that output that you want? So try this on page 6 of your notebook.